Yesterday, we talked about our parent functions for sine and cosine, and today we're going to talk about transforming them. So there's a few reminders here of what the different pieces of our function do as far as transformations go. So starting with our value a, which is found at the front of our function, it says that this has to do with your amplitude or your maximum and your minimum. And your a value is what would cause your maximum or minimum to change. Your maximum being your highest point of your graph, your minimum being your lowest. So if your amplitude is in charge of that, what that does is it means that it either stretches those 2 points to be higher and lower than they originally were, or compresses them to be closer together than they originally were. And that would be what we call a vertical stretch or compression. It also says here that if your a value is negative, it causes a reflection over the x-axis. Your b value, which is found right beside x, usually multiplied by your x value, is going to control the period of your function. So we talked yesterday about how the entire cycle of sine and cosine's graph occur between 0 and 2 pi. After 2 pi, it just starts to repeat itself because you would start going around your unit circle again. So while our period is normally 2 pi, you take 2 pi and divide it by your b value to determine if your pattern is now going to happen in a shorter span than 2 pi or a longer span than 2 pi. So this is going to be something that affects your horizontal stretch and compression. It also says that if your b value is negative, this can cause a reflection over the y-axis. Then it has your h, which is inside your parenthesis with x. That's called your phase shift or your horizontal shift, which just means we shift things left and right, and it's always the opposite direction of what that sign says, so opposite of what we would think it would be. And then your k value is this value out here on the end, which is a vertical shift. It's going to shift things up and down. So first thing we're going to do is we're going to look at these two functions, and we are just going to write out in words the changes that would be occurring here. So first, we've got our a value. Here it's -2. So a is -2. And this means two things. The fact that it's negative, remember, means a reflection over the x-axis. So we would have a reflection over the x-axis. And then the value 2, the number 2, is larger than 1, which is our typical maximum or minimum. So 2 would be an increase. So we would say that this is a vertical stretch to our function by 2. From there, we would need to then identify our b value. Our b value is that part that's in there with x. So our b value would be 2, which doesn't mean a lot to us on its own, but we were told here that we can use that to help us find the period of our function. So you take 2 pi and divide it by b. So 2 pi divided by 2 is going to give us 1 pi, or pi. Oh, sorry, it's not 2, it's 4. So b would be 4. So if I put 2 pi over 4, this would simplify to pi halves, or 1 pi half, or we would basically have a coefficient of 1/2 with our pi there. So 1/2 would be less than what our typical period is, which is 2 pi. So we would say that this is a horizontal compression. of 1/2. All right, then we would need to identify h. H should be in here in the parentheses with x, and since there's nothing there, we let that be 0. That means there is no left or right shift. And then k is our value out here on the end, which is 5, which tells us that we are going to shift up 5 units. All right, for B. Again, first we need to identify our amplitude, which would be 5 here. So my A is 5, and what this means is that we would have a vertical stretch by 5. I then would want to identify my B value. B, again, is going to be the part inside our parenthesis being multiplied by x. So x is being multiplied by 1/3 here. So I would say my B value is 1/3, which again doesn't mean a lot to us on its own, but it will help us find the period of our function. So our period would be 2 pi over 1/3. We don't like a fraction in a fraction, so we would keep 2 pi, change to multiplication, and flip 1/3 over to give us 3. So our period is 6 pi. This is an increase from 2 pi, so we would say that we have a horizontal stretch of 6. I then would identify h and k. Again, there is no h value in this parenthesis, so h is 0, which means we didn't shift left or right any. My k value is out here on the end, and it's -10. So this means we shift down 10 units. So now that we can identify what the changes are we're supposed to be making, now we're going to take a look at our functions and graph them. So it says that if we were to transform these on a graph, first we would want to do exactly what we just did on these 2 previous examples. Find the altitude, find the period, find the horizontal shift, find the vertical shift. But in addition to that, we also need to know what the pattern is for our sine and cosine functions so that we know what points we're trying to make our changes to. So for sine, it says we would start at 0, 0. So yesterday, when we graphed the parent function for sine, it started at 0, 0. Okay, so 1/4 of that period over 2 pi, we said our first point that we plotted yesterday was at pi halves, and we plotted it at 1. Okay, from pi halves, halfway through our period was pi, and by that time I'm back at 0. And then 1/3 of the way through, I'm at 3 pi halves, and this is when we went down to our minimum value, which would have been at -1. And then at 2 pi, I should be back at 0. So we said yesterday our parent function for sine looked something like this, where our 1 and -1 were our maximum and our minimum, according to this chart. Okay, so any changes we make are made to these points. For cosine, we would start at 1. So yesterday, our first point would have been up here at 1, which is our typical maximum on the parent function. Okay, and then when I get to pi halves, I'm at 0. When I get to pi, I'm now down here at my minimum value, -1 on the parent function. At 3 pi halves, I'm back at 0. And by 2 pi, I'm back where I started at -1. So our graph looked something like this. So when I make changes to my graph, I'm making changes to these points. It says we will want to label our axes so that we can use appropriate measurements for the shift and the period, and to look at your amplitude and your vertical shift to determine the height or the increments in which you want your y-axis to increase. And then you need to look at your left and right shift and your period to help you determine your horizontal increments of measure. All right, so for this first example, first thing I want to do is identify the transformations that we need to make. So I'm going to start with identifying A, which is 2. This tells us we're going to have a vertical stretch by 2. I then want to identify my B value. My B value is the coefficient of x, which is just understood to be 1. So that means my period is not going to change. 2 pi over 1 is still just 2 pi. So my period will not change. And then I need my h. Well, there is no h value. Yes, there is this time. My h value is negative pi fourths. Negative, opposite of what we think, means for us to move to the right pi fourths. And then my k value out here on the end is 1. Positive 1 means for us to move up 1 unit. All right, so something to keep in mind is that the changes I make here are the changes to the sine parent function. So this graph right here that I just circled in red. So normally that graph starts here at 0, 0. But we have shifted right pi fourths and up 1 unit. So in order to keep it easy for myself, I am going to make each one of these lines worth pi fourths. So this would be pi fourths. The next line would be pi halves. Skip a line, the next one would be pi. Skip a line, the next one would be 3 pi halves. Skip a line, the next one would be 2 pi. All right, so I'm going to move to the right pi fourths, but it also says to move up 1 unit. So this would be my new starting point, or my new 0, 0. I have shifted it pi fourths to the right and up 1 unit. Okay, so from here, I normally would go up 1 unit. But they told us that we have a vertical stretch of 2. So 2 times 1 tells me I'm actually going to increase by 2 instead of 1. Okay, and if I look here, these points occur every pi halves. So pi halves would be every 2 lines. So I'm not going to plot another point for 2 lines to the right. And I move up 2 units because of my vertical stretch instead of moving up 1 unit. All right, from my maximum, I now am supposed to come back to 0, or in this case, 1. And then I'm supposed to now graph my minimum. So normally I would move down 1 line, but since we have a vertical stretch, I move down 2 lines to put me here at -1. And then I'm supposed to go back up to 0, which in our case is at +1. So my new graph looks something like this. All right. For B, it says that our A value is -2, which tells us 2 things. It tells us that this is a vertical stretch, but it also tells us that we have a reflection over the x-axis. My B value, again, is the coefficient with x, which is understood to be 1. So this means the period won't change. It's going to stay 2 pi. we also are told that our h value is 2 pi. Plus 2 pi really means to shift left 2 pi. And then my k value out here on the end is -3, which means to shift down 3. All right, and this is for cosine. So now I'm looking at this parent function. So normally it would start here at 1, but it's been reflected, so I'm going to start at -1. Okay, but I also have some transformations I need to make. So in this particular case, we were told to shift left 2 pi, and if I make every line worth a 4th pi, I only have enough room to go to the left pi. So I'm going to have to make each line worth pi instead of a quarter or even a half. So I'm going to say that this is pi and that this is -pi. So if I shift left 2 pi from the y-axis, then I would move to -pi all the way over here to -2 pi. But then I'm also told to shift down 3 units. So that would put me here. So my new starting point is here. And instead of it being a maximum, I was reflected, so now it's a minimum. So normally my maximum would then head to 0, so my minimum should now head towards 0. Well, since we've made our shift, we did have a stretch of 2. So that 2 tells me that instead of going up just 1 line, I am going up 2. But my next one should be at an increment of pi halves. Well, if each line is worth pi, pi halves would be right in the middle. So my point would be here. So that would be this point equivalent that I just plotted. Okay, then next I would go to my minimum, but since I reflected, that's now up here as a maximum. So I would move up 2 lines again and over another half, pi halves, which would put me at -pi. And then I would go to 0, which we said was right here at -2. And then normally from there, I would be going up to a maximum, but we reflected, so now it's a point down here as a minimum, which would put me right here. So now my entire graph has been condensed just because of the lines we had to fit it in, but it did take place from here, which was at -2 pi, to here, which would be 0. So it did take place over the course of 2 pi. All right, so these are the 2 that you would have done with a partner. So let's go over these. So here, my a value would be -3, which again, this is going to mean not only a vertical stretch, but it also means a reflection over the x-axis. My b value this time is 2. So what this means is that my period, 2 pi, is divided by 2 and now is a period of 1 pi. So now, instead of taking course between 0 and 2 pi, it would take course between 0 and pi if no shifts were made. Okay, and then we talk about our horizontal shift, which would be my h. It says plus pi force. So plus pi force would really mean to move to the left pi fourths. And then my k value, there is not one, so I'm not moving up or down any. And this is our graph for sine. All right, so sine normally would start at 0, 0, but it has been shifted left pi force. So I'm going to do exactly what I did on the graph right above it and make each line worth pi force. So if each line is pi force, then this would be pi halves right here, and this would be pi. All right, so keeping that in mind, again, sine would normally start at 0, 0 at the origin, but we were told to shift to the left pi 4. So I'm going to shift to the left one line since I'm making each line an increment of pi 4s. Okay, I would then typically go to my maximum, which is 1, but I was told I have a stretch of 3. So my new maximum would be 3. And I was told that it's reflected. So now instead of going up 3 for my next point, I should be going down 3. And this all occurs in increments of pi halves typically. But now this entire cycle is supposed to happen over a period of pi. So it's double time. So instead of every pi halves having a point, I'm going to have a point every pi fourths. So my next point would be here at -3. I then go back to 0. I then would need my maximum since it's been reflected. Now I have a maximum. Then I'm going to go back to my 0. And there's our full cycle. So would look something like this. So it's been stretched, it's been shifted left, and it not only has been stretched vertically, but horizontally it's been compressed, so it doesn't reach quite as far. All right, and then we got one more to look at here. So for this one, our A value is 1/2, which would mean that we have a vertical compression. Okay, our B value is 1, so this would mean our period is going to stay 2 pi. My H, since it's negative pi 6, means we're going to move right pi 6. And my K, being 2, means we're going to move up 2 units. And this is for cosine. So cosine would normally start at 1, which, let's make our lines increase on the y-axis in increments of 1/2. So that would make this line 1. And this line would be our -1. All right, and then pi 6, if I'm moving to the right, pi 6, and each line is pi fourths, then that's going to make pi 6 in between the lines here. All right, so cosine would normally start at 0, 1, but we do have a compression of 1/2, so 1/2 of 1 would have been here, but then I also have it being shifted up 2 units. So up 1 unit would put me here at 1.5. Up another unit would put me up here at 2.5. So 1/2 plus 2 is 2.5. So this would be my starting point. Okay, and that would normally be my maximum. So I'm starting high, and then I'm going to go down towards what would have been 0, but I have been shifted up 2 units, and I had a compression of 1/2. So that would put my next point right here on this line, which would be at 2. So again, remember we had to make in between the lines be equivalent for our pi 6. Oh, I apologize. I didn't shift that first. Okay, let me start those points again. So this is my 2. Let me do that in black. So this line is 2. This line is 1, -1. Okay. So whenever I said that it normally would have started at 1, but it had a vertical compression of a half, 1 times a half would have moved me back down here. And then I would have had to shift up 2 units. So a half plus 2 would put me up here at the top. And we also are told to shift right pi 6. So pi 6 would not be a full line over, so that would put my point right here. Okay, so there's my starting point. Okay, and then from there, I would need to go back towards my 0. And my 0, instead of going down to 0, I have a vertical compression of a half, and we were shifted up 2 units. So that would put my next point right here. And then my minimum would be, oops, sorry, I went one too far down. So I would be here, and then again I would be back in between because of that shift. And then I would be back here. And then finally I'd be back in between right here. So our graph would look something like this. Oops. Here we go. So this one's not near as deep because of that vertical compression of 1/2. It doesn't seem to dip near as low or to have a maximum near as high. And we also were shifted up quite a bit.